This next example says to factor this cubic function fully. In order to do that, we're going to first try and guess and check to find a factor. Once we find a factor and confirm, we're going to use polynomial division, and that's going to help us end up with a quadratic, which we then use our quadratic factoring skills to solve. So firstly, I want to find a factor. And to do that, I'm going to work with this value of negative 15. One of the factors of 15 is guaranteed for me to be one of the factors of the entire cubic. So factors of 15 are plus and minus 1, plus and minus 3, plus and minus 5, plus and minus 15. So to find a factor, I'm going to slowly work with these numbers and substitute them into the equation to see if I get a y value of 0. So function notation, remember f of 1 is exactly the same as y. F of 1 is equal to 1 cubed plus 3 times 1 squared minus 13 times 1 minus 15. I can see right away I'm going to have a small positive number take away 28, so this does not work. I go test another value. I'm going to use f of 3. And remember, you might have to use the negative numbers as well. F of 3, when we substitute that, gives us 3 cubed plus 3 times 3 squared minus 13 times 3 minus 15. 3 cubed is 27. 3 squared is 9 times 3 is also 27. 13 times 3 is 39 minus 15. I end up with 54 minus 54, which is 0. If plugging in 3 gives me 0, I know that this is an x-intercept. And the factor that goes with an x-intercept of positive 3 is the bracket x minus 3. So I've now found a factor. And now with that factor, I can apply polynomial division to simplify the cubic down to see what's left that I can end up further factoring. So I'm going to write this out and apply polynomial division. This is being divided by my factor x minus 3. X divides into x cubed, leaving x squared. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. I subtract everything to see what's left. X cubed take away x cubed is nothing. 3x squared take away negative 3x squared is the same as adding. This becomes 6x squared. And I bring down a term. X divides into 6x squared, leaving 6x. 6x times the entire factor gives me 6x squared minus 18x. I subtract to see what's left. 6x squared take away 6x squared cancels out. Negative 13 take away negative 18 is the same as adding 18. So I end up with positive 5x minus 15. X divides into 5x, leaving 5. 5 times x is 5x. 5 times negative 3 is negative 15. And no surprises, we have no remainder. We should never have a remainder when we're dividing by an actual factor. We now have our quotient at the top, so we're able to conclude that our full cubic that we started with can actually be written in partially factored form as x minus 3 times x squared plus 6x plus 5. If we multiply these out, we would end up with the expression on top, but we're trying to work in the opposite direction and actually factor. We use our quadratic factoring skills to factor this simple trinomial, two numbers that multiply to 5 and add to 6, or 5 and 1. So I can factor that right away, and there's my fully factored form. In order to find that, I had to go through the polynomial division process.